So we've talked about the definition of our trig functions based on a point traveling around the coordinate system with a vertex centered at the origin. And that is one way for us to define our trig functions. But there's also another way to define our trig functions, and that's based on simply right triangles. So what happens if I'm looking at a triangle that is not overlaid on a coordinate system? How do I go about finding those function values if I don't have an x and a y to be able to associate with it? So that's where we have a different way for us to talk about right triangle definitions, and that has to do with the hypotenuse of the triangle, some side that is opposite and some side that would be adjacent. Now, typically, if you've ever heard of this, the acronym that helps us remember sine, cosine, and tangent is SOHCAHTOA. So SOHCAHTOA. Now, if I want to use that acronym, what that tells me, if I have the sine of angle A, then the sine of angle A is the ratio of the side opposite angle A over the hypotenuse. So opposite the angle over the hypotenuse of that triangle. So that's where we get the SO from. Now let's think about CA. CA has to do, of course, with cosine. With cosine, if we're talking about the cosine of angle A, the ratio of that function value would be the side adjacent to angle A divided by its hypotenuse. And then last but not least, we have tangent. Tangent of angle A has to do with the side opposite angle A divided by the side adjacent to angle A. So all of that's to say that if you're looking at this green box over here on the left, the way to remember, well, which one is it, opposite, adjacent, or hypotenuse, is through the SOHCAHTOA. SOHCAHTOA. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And it all depends on what angle that we happen to be talking about. So let's come down here and we're going to find sine, cosine, and tangent of both angles A and angles B for the figure that you see given here. Now, it helps when I'm looking at this to be able to identify the angle that we want to be specifically referring to. So I'm going to come over here just to be clear, and I'm going to circle angle A. So angle A is the angle that I'm referring to, and if I want to find sine of angle A, the sine of angle A, well, that's defined as opposite over hypotenuse. So the side that is opposite angle A happens to be 7. And the hypotenuse of the triangle, of course, is that slanted leg, which would be 25. So the function value for the sine of angle A is 7 over 25. So the cosine of angle A has to do with adjacent over hypotenuse. The side that is adjacent to angle A is 24. And the hypotenuse is, of course, 25. Now let's look at tangent. Tangent of angle A is opposite over adjacent. Opposite of angle A, we already said, was 7. Adjacent to angle A is 24. So these are the three function values if I wanted to know for angle A. Let's come over here and let's do a similar idea when we think about angle B. So I'm going to circle angle B just so that it's clear for us. The sine again of angle B is going to be opposite over hypotenuse. So the side opposite angle B is 24 this time. The hypotenuse is 25. Let's go with the cosine of angle B, which would be adjacent over hypotenuse. The side adjacent to angle B is 7 this time. The side and the hypotenuse is 25. And then of course we have tangent of angle B, which would be opposite over adjacent. So the side opposite angle B is 24 divided by the adjacent side of 7. Now, we could come back in and figure out what cosecant, secant, and cotangent were because we already know the reciprocal identity, so we could apply those if we needed to in determining the remaining function values for either angle A or angle B once I already had the first three done. So that's how we can go about using right triangle definitions for triangles that don't happen to be falling on our on our circle.